My name is Rishi Patel, and this is my video lab report presentation for Physics 2212. The purpose of this experiment is to determine the amount of excess charge on a piece of charged tape. Using this data, we can establish an idea of charge and their interactions for simple household materials. This is important because it helps us better understand the laws of physics and the concepts used throughout the lab. The fundamental principles and concepts are Coulomb's law, which is an equation that relates the force of a charge using the charge of two particles and the distance between them, the electric field, which is used to find the vector field value of a charge from an observation location, the force of gravity, which is an important natural force observed in the main part of the experiment, and the relation between force and the electric field, which is found by a charge multiplied by the net electric field. Before beginning the main part of the experiment, a few key assumptions and observations must be made. The first assumption is that two charged U-tapes should repel against each other but attract to other objects. When bringing two charged U-tapes closer together, they repelled against each other, but it attracted to regular objects such as my desk. If a positively charged U-tape interacted with a charged pen, then it should attract, but if negatively charged, then they would repel. When I rubbed the plastic pen against my hair, the pen gained a negative charge. When bringing a charged U-tape close to it, they repel against each other, which means the sign of my U-tape is also negative. Now we can discuss the main experiment in further detail. Essentially, after acquiring two pieces of charged tape, tape B will be placed in this manner and tape A will be brought towards tape B. Because of like charges, tape B will be repelled by tape A and flow upwards. From this, we can measure the distance and calculate important quantities. Other important quantities from the experiment are the mass of tape B, the distance between tape A and tape B, the width of tape B, and the length of tape B. Important calculations for this lab are shown as they are. First, after drawing a free body diagram of tape B as it was floating, we find that the electric force from tape A acting on tape B is the same as the electric force due to gravity acting on tape B. This means that they have the same magnitude but act in different directions. We also must assume that tape A and tape B must have the same charge. Knowing these quantities, we can use Coulomb's law to find the charge of tape B. I set the force of gravity equal to the expression for Coulomb's law, and after isolating the charge of B, I can plug in my numbers and solve for QB. For QB, I got 1.1346 times 10 to the negative 8th power coulombs. Shown now are other calculations used for this experiment. The main quantities on this slide are the total number of atoms in the tape and the number of deficient electrons. These quantities are used for the ratio of electrons to total atoms, which ends up being 1 electron for every 5 times 10 to the 9 atoms. These quantities could be wrong because of certain errors that could have occurred in the experiment. One error is that the tapes may have not been charged correctly, and that the distance that was measured between them may have also been measured incorrectly. Shown now is the computational model for my experiment. First, in order to use this model, I must set initial values and constants. Next, I found the gravitational force and also the charge on QB. Using these quantities, I was able to create a function that calculated for the electric field on charge B. Here are the results from my model. The gravitational force at tape B and the electric force at tape B have the same magnitude but different directions. The charge of tape B is 1.13 times 10 to the negative 8th power coulombs. This quantity is comparable to the quantity that I calculated for in the previous slides. The electric field at tape B is acting in the positive y direction. Assumptions, approximations, and idealizations. The first assumption is not valid because there is no moving object in the experiment, which means there is no air resistance. The second assumption is valid because we have been treating our tapes as a point charge throughout the entire experiment. The third assumption is valid because we are assuming that the charges on each tape are the same because they were made the same exact way. What if electrons had positive charge and protons have negative charge? Well, nothing would change. The observations made during the experiment would remain the same. Our conception of negative and positive charges would be swapped, but the way charges interact would still have the same effect. Why is it important to handle the charged tapes as little as possible? Depending on how the charged tapes are handled, electrons may transfer on the tape due to an electron efficiency on the charged tape. This transfer happens when having contact with things such as your hand or even objects such as your desk. This would cause inaccuracies in the data and change the outcome of the experiment. It is important to limit contact with other objects as much as possible so the outcome of the experiment is not skewed.